Okay, so hi everyone, I'm Leslie. I'm presenting Lgsl today, which is a Lua module for numerical algorithms. So it gives you a very friendly Lua-ish interface to the GNU Scientific Library. I should stress I'm just one of the authors. It was actually started as Lgsl, as GSL shell by Francesco Abate, with big contributions from Benjamin van Erden as well. So what is Lgsl exactly? So like I said, it provides a very friendly and intuitive interface on top of the GNU Scientific Library. And it's based on the modules, numerical modules of GSL shell. The way it's implemented is that it uses the FFI, or foreign function interface bindings, to functions from the GSL library. So the nice thing about this is that you do not have to compile anything. The FFI library just allows you to link directly to the shared library of GSL. And of course, we want this to be a real alternative to writing C applications. So that means that performance really matters. And as you know, Lua-JIT is really fast, one of the fastest dynamic languages implementations. And also thanks to the fact that you can use a custom BLAS implementation, Lgsl is blazingly fast. So let's look under the hood. It uses Ffi Meta Types. This is a bit like a meta table, but it's applied on a kind of an Ffi type. So this is typically a C type, like a certain struct that represents a matrix. And so it turns these C types into very featureful and garbage collected, which is very important, Lua objects. So an example here is the matrix class, which you can require. It's a submodule of Lgsl. You can create matrices, so you can have like element-wise subtraction of a scalar. So this all mixes very well. You can invert them, solve systems, and it can also be pretty printed. And thanks to operator overloading and so on, you can mix all kinds of objects like matrices, scalars, and complex and real numbers. And this is all handled very gracefully. Now finally, even though these objects are very featureful Lua objects, you can still just pass them to all the GSL-C functions. So a second example is the complex number, which is actually already supported in Lua-JIT, but the problem is you can't do anything with them. There are no operators defined on them. And Lgsl also provides these operations. But of course, if you want to do some math operations, you will need them from the Lgsl complex module. The regular math library won't work on complex numbers. So all the operations are defined like division, and here taking the power of I to the ith, which is a real number, surprisingly. And here's an example where you have the exponent, the complex variant of the exponent function. So using these basic types, you can start implementing or writing nice wrappers around the GNU Scientific Library. But I should first stop for a while and explain why the GNU Scientific Library is an interesting library to use. So first of all, it's very well written. It's quite, well, at the time, modern object-oriented C. It's ANSI-compliant C code. It's very well tested. It has a massive test suite. And it's also had years of field testing, which is very important if you want to really depend on these calculations. It has a very good reference manual in print, actually. And maybe most importantly, or it might be repellent to some, it's free as in freedom. That means it's GPL licensed. So you can freely share your applications. And if you have a look at the website, you see the following here. The interface of GSL was designed to be simple to link into very high-level languages, such as GNU-GUIL or Python. And of course, a grave omission here, or Lua. So it's a very extensive library, and not everything is provided yet in Lgsl. So I'll just put everything that has a nice and Lua-ish interface in bold here, and the things that only have bare FFI bindings in red, like this. It's not very clear, but I'll publish the slides. In principle, it's easy to add some more red items, but that's not the idea of the library. We don't just want to provide bindings to FFI I mean FFI bindings to the C functions, we really want to have a nice interface as well. So why would you want to use Lgsl and not just write a C application? Because to be honest, it's already, I mean, a C application for GSL functions is already relatively simple and elegant. So here's a C implementation of a Monte Carlo integration. So you include the necessary headers, you include some like integration bounds, you allocate everything that you need to allocate, your spaces, do a manual loop, check your convergence criterion, and then at the end, don't forget to free your resources. Now in Lua, this becomes a bit simpler. So you could require the two modules, Vegas and matrix that you need. You define your bounds again, and then you just call vegas.integ to integrate the function and print your result. So I told you that it's blazingly fast, and maybe some of you are already thinking, what integration with C functions? And so one of the tricky bits about using GSL is that you will need callbacks to integrate a Lua function. So a callback, that means that you're calling a C function from Lua, which in turn is calling a Lua function. And thanks to the LuaJIT FFI, this is possible, thanks to magic and careful planning, I think, according to Mike. And, but the problem with this is that these calls cannot be optimized, so they cannot be inlined. And so if you would just naively use the FFI bindings and call quadrature algorithms, ordinary differential equation integrators, everything that calls a function thousands or even millions of times, it would carry a very high performance penalty. So the solution is actually to re-implement the algorithms in Lua. So the following functions were re-implemented in Lua. So typically the ones that call Lua functions a lot, like quadrature, sorting, Monte Carlo integration, differential equations, and root finding. But this is not yet in the main branch. Now, you have to know that if you really naively re-implement something in Lua and you run it, it's already very fast with LuaJIT. So, but you have to keep in mind the following guidelines, like using locals, and this is the same for Lua and for LuaJIT, in fact. Cache the functions that you use a lot, minimize the number of live variables. That means not putting all of your variable declarations at the top. I mean, it's not Fortran. Use numeric for instead of pairs if you want it to be fast. Avoid unbiased branches. And the last point is important. Avoid nested loops or loops with very low iteration counts. And if we would really want to compete with C, then it becomes very tricky to combine this last item. Like, don't avoid nested loops or small loops. It's hard to combine this with flexible code. So how is this fixed? So to incorporate this, I mean to avoid having these low iteration count loops, the loops are enrolled automatically using the template parser originally written by Luci Lake. So as an example here, this is one of the steps in the fourth order Runge-Kutta ordinary differential equation integration algorithm. So there's the main integration loop, which is called thousands or millions of times, and inside that you have these small loops over the number of dimensions. So the way to solve really having these small loops block slow down your process, because they will never get hot because they're not executed frequently enough. And the way to do this is to first do a pass over a template. The templates here are indicated with the hashes in front and also with the dollar signs. Unroll the loop first and only then include the code. So this only works for very small numbers of dimensions. If you have a very large ODE system, you should use ODE-VEC, which is also still under development. And a final tip, of course, is to use FFI arrays instead of Lua tables to speed things up even more. So I can't run the demo here, but fortunately I have exported some of the images. So if you want to visualize your adventures with Lgsl, I recommend Graph Toolkit, which is also started as a component of GSL shell. And the two play very nicely together. So here are some examples of visualizations of the features: linear fitting, Fourier transforms, ODEs, and so on. And here are even more examples. So I would encourage you all to try it out. If you will first need some requirements like Lua-JIT, please install it. It's only 2 lines of code, even if you don't want to use Lgsl. It's and use Lua-Rocks to install it, because to install Lgsl, because it's really the distribution mechanism of choice nowadays for Lua modules. And if you want to plot the things that I just showed, do install Graph Toolkit. It's very neat, very fast. So finally, installing GSL. Usually GSL ships with your distribution, and then it's just a one-liner. Lua-Rocks install Lgsl. So the documentation is available here. And please visit my GitHub page, because pull requests are always welcome. Okay. Thank you very much. Questions? Yes? You first, maybe?
Do you support sparse matrices?
No, sparse matrices are not supported yet. But if there's enough demand, I can look into it, of course.
So it's supported by GSL?
It is supported by GSL, yes, yes. Yeah. Definitely.
For callbacks, when you go back into Lua, you use all the vectorization that you could do on the CPU, like SSE or so.
In fact, there is, currently there is no auto-vectorization in Lua-JIT. So I hope I'm not lying here. But what do you mean exactly?
Would it even be possible to have the Lua-JIT vectorized code or the bytecode?
I think it would be possible, but it would be quite
so I think it would be also a major reason to leave this part in C, especially the callback.
Yes. Yeah, but of course, as a user, you want to be able to define your function in Lua and just give it to an integrator. So that's the main issue.
It's not a big issue for like slowing down the computation. I mean, if you compare the same calculation in Lua compared to the native C code, you make benchmarks.
Yeah, I made some benchmarks. I can't show them now, but it's like, I don't know, 10-20% difference at most. And actually, if I use the non-optimized GSL, and I compare to the Lua implementation, then the Lua implementation is faster. So for the integration, so that's nice. Yeah. Yes.
Maybe you said it, and I apologize if I didn't get it. But what's the status? Is this an alpha, or is it production somewhere? Or?
I just released 0.1.
0.1.
Yes. So I've used it myself not in production, for research. So yeah. Yes.
The BLAS interface is now just FFI. Do you think it's doable to make a nice Lua interface above it, because BLAS is huge?
Yeah, not for everything, I think. I don't think that's also what we need. So maybe it's not necessary to expose everything in BLAS anyway. But actually, you can already use everything. I have to be careful what I say. The main features of BLAS, because these are there's like a raw lgsl.gsl module in which all the GSL exposed functions you can just use them. And there are some BLAS functions in there as well. And adding BLAS functions is just adding a CDEF statement, so yes. Yes.
Any more questions? Let's thank once again the speaker.